go. So, I hope you all had a wonderful long weekend. How good, eh? So, we don't have too long to go. We've got a few things to get through. What we're on today is 7C, so that's the cosine function. So we'll be looking at the cosine graph. So we're hopefully pretty confident with the sine graph and how to find the equation of that and how to move it around. So today I want to refresh you with the sine graph, how we generate that function, right? And so remember, this is the unit circle. So for this first part, I reckon just watch. This is conceptual, okay? It's important that we understand the concept of it. So we just watch to start with. So remember, we've got some point traveling around the unit circle, and the position of that point is dictated by the angle theta. All right, so the larger theta is, the more the point's going to move around. Okay, so that's what we have on the x-axis for our graph here. We have the angle theta. All right, and we're doing the graph of y equals sine theta. That means the y value on this graph is going to correspond with the y value on the unit circle. So we can see when the angle is zero, the y value is 0. And so we have the angle is 0, the y value is 0. All right? And so what you'll see, as I move the point around the unit circle, okay, as the angle increases, the y value increases. Look, the y value is getting larger, and it's going to keep getting larger until we get to this point, until we get to this angle pi on 2. All right, and so that corresponds with this point here. All right, I'm going to keep increasing the angle, but the y value is going to get smaller, and then you can see it becomes negative, and so forth, and it just keeps going on and on and on. Okay, we can just keep cranking that angle around. All right, and then we can go back the opposite way as well. So that's how the graph is generated. That's what it's a graph of, right? Now, we're going to do the same for cos today, all right? And so they're going to be the same graph, except a horizontal translation. We'll look at that in a moment. So on the x-axis, we still have the angle theta, all right? So again, we've got that point moving around the unit circle. On the x-axis, we've got the size of the angle. This time on the y-axis, we're going to have the cosine value. And on the unit circle, the cosine value is the x-coordinate. So it can be a bit confusing because what we're doing is we're taking the x-coordinate of the unit circle and plotting that on the y-axis. All right? So when the angle is 0, the x value is 1. That's why we start at a peak. When the angle is 0, the x value is 1. And we can see as I increase the angle, the x value is going to get smaller and smaller and smaller. Okay, hence as I increase the angle, we've got the function y is equal to cos of theta, y is equal to the x value is getting smaller and smaller and smaller. Okay, so hopefully we can see that as I move around. All right, the x value is getting smaller and smaller and smaller, and now the x value is getting negative, so it's going below the x-axis, and now the x value is getting larger, but it's still negative, and then it's getting larger, and then it's, it's positive, and it's at its maximum point there. All right, so that's where we have the biggest x value, right? When the angle is 0, and we have the most negative x value when the angle is pi on pi. All right, so that's just conceptual, okay? That's understanding where the graphs come from. And we actually tried to do a bit of that when we did this activity here. All right, so maybe you can't see it very well because it's on its side, but we started with we put in angles and we put in the cosine values and we plotted them, okay? So that's an activity that you can do to help you understand that a bit further if you would like. Okay, nonetheless, you don't really need to understand where they come from. All we're doing is using them. So I'm just pointing it out for interest's sake. But let's jump over here, and I'm going to graph the sine of x function, and I'm going to graph the cos of x function on top of one another, so that you can see that they're the same function. One has just been shifted, okay? And in fact, if I change my scale here, you'll be able to see how much. I'm just going to change this to a scale of pi on 2. All right, and we can see, all right, so the blue one is the cos function, The red one is the sine function, and that point is shifted pi on 2 units further along. So that means I could perform a transformation. I could move the red function. I could move it to the left pi on 2 units. All right, so I'm going to go here, sine of, how do we do horizontal? It's x plus pi on 2, close my bracket. And now they're the same function, okay, because I've moved the sine function pi on 2 units to the left. And so if you were to jump back in exercise 5, I'll have to check, 5D I reckon, we have a couple of these identities. Sine of x plus pi on 2 is equal to cos of x. Cos of x, take pi on 2, is equal to sine of x. All right, if you're to move the cos of x function, so I'll delete this translation now. So we got the sine x cos x. And if I move this one pi on 2 units to the right, okay, you can see we've moved the cos x function. All right, so all of that build up is to say sine x and cos x are the same function except the horizontal translation of one another. So then when we get into the exercise today, 7c for the cosine function, the same rules apply. All right, remember how we have the general sine function was a sine b of x takes c plus d. It's the same for cos, except we have cos written there instead of sine. All right, so all of these values affect it the same way. All right, so when it says to sketch, okay, that's something you can do using your calculator. All right, but I'm going to do this one without my calculator because I know what each of these values does, and it's probably a good opportunity for us to discuss it, right? So I might do it over here because I'm going to scroll down a bit more in a sec as well. We have the function 2 cos of x on 2 plus 3. Okay, so you can go straight to your calculator, punch it in there and solve it. All right, but let's do it manually. So let's refer to these points. Firstly, we have A is the amplitude, all right, that number out the front. So our amplitude is 2, all right? And so what that means is the distance from a principal axis to a peak and the principal axis to a trough, that is 2 units. That's how far it's traveling from the principal axis, right? How about our value of B? I'm saying watch out for this. Remember, when we have it written like that, another way it can be written is like this, okay? We take it as x on x divided by 2 is the same as half of x. And so our value of B is half. Okay, and we can understand that in 2 ways. The first way is to say that there is half a wavelength in 2 pi. There is half a wavelength in 2 pi. Or, remember, the wavelength is 2 pi divided by B. So if we do 2 pi divided by half, we get 4 pi. And of course that makes sense, all right? If there's half a wavelength in 2 pi, well then there's one whole wavelength in 4 pi. All right, so a connection there with B. All right, then on to C, horizontal translation. I've said we tend not to deal with them because it makes the graphs messy. So if you do, you use your calculator. And then the last one, D, is a vertical translation. So we've been shifted up 3 units. D equals 3. All right, so plus 3 moved up 3 units. We've got everything we need to graph it. So if I'm going to graph this, all right, here's my x-axis, here's my y-axis, and we're going to start with the principal axis, which is a vertical translation of 3. So 1, 2, 3, 4, 5. All right, and I might put numbers there, 2, 3, 4, 5. So this is the principal axis, right? This is the line about which the graph propagates itself. All right, and we have an amplitude of 2. Okay, now let's just sketch this up here quickly. This is a sine of x function. This is a cos of x function. The difference is sine of x starts at 0, cos of x starts at a peak. So I'm going to start at a peak, and my amplitude is 2. So I'm going from the principal axis up 2 units. That is where I'm going to start. All right, and I'm just going to draw a cos of x function, and then I'm just going to put my period in later. All right, so if I go up 2, that means I'm going down 2 as well. All right, amplitude is 2, 2 from the principal axis up, 2 from the principal axis down. So we've got a peak going into a trough and then coming back up to a peak there. And I'm going to cut the graph off there. All right, we've drawn one wavelength of it. We could draw more, it's just going to keep going, right? It's just going to keep going. All right, so we've used A, we've used the amplitude, we've used D, we've used the vertical translation. Now it's time for us to put a horizontal scale in. And we said there's half a wavelength in 2 pi. All right, that's what that tells us. Half of a wavelength, all right, in 2 pi, which means there's a full wavelength in 4 pi. What's a full wavelength? One whole peak and one whole trough, okay? Or peak to peak. Peak to peak is a whole wavelength. Okay, so I've sketched that just from the information that we know, right? And so we've done exercise 7B. All right, we seemed pretty confident with that last Tuesday when we ticked it off. So hopefully that sort of flows on. But again, when you're asked to graph from an equation, you can just use your calculator. Okay, let's go down one then. We've got question 2. Find the equation of the following cosine graph. So now we're just doing the opposite, right? We're starting with the graph and going back to the equation. So the first thing we'll start with is the principal axes. All right, so remember we want to find these values, A, B, D. All right, I'm saying we tend to ignore C. All right, so in your test you won't have C involved at all. They may pop up in the textbook, but won't be with C in the